Hello everyone. Today we are going. Last class we saw about the open loop and closed loop control systems and its various examples and comparisons. Today we will be talking about the LTI systems. We will be starting slowly moving into the modeling of various systems. So LTI system stands for linear time invariant systems, which means a system that is both linear as well as time invariant. So first we need to look at the terms linear and time invariant. When I say linear, it means the system can support two other principles, which is the principle of superposition and principle of homogeneity. So suppose if an input x1t produces a response y1t and the input x2t produces a response y2t, then the scaled and summed input a1x1t plus a2x2t will give you the response a1y1t plus a2y2t. Here a1 and a2 both are complex scalars. And when I say time invariant, it means if the output due to input x of t is y of t, then the output due to input x of t minus t is y of t minus t, which means the system is time invariant because the output is not depending upon the particular time the input is applied. So such a system where both the principle of homogeneity and superposition is involved, that is a linear system, and a linear system plus a time invariant system becomes an LTI system. No. So let's start with our mathematical models of control system. The input-output relations of various physical components of a system are governed by differential equations. Okay, any system you take, you can relate the input and output through differential equations, and the mathematical model of a control system is going to consist of a set of differential equations. The model will be linear if the differential equations described in the system has constant coefficients. So if the coefficients are constant, the model is said to be linear time invariant. Now the differential equations of an LTI system can be reshaped into different forms for convenience of analysis, and one such model that we are going to use is known as the transfer function of the system. Let's define or see what is a transfer function. Transfer function. So the transformation meaning ആണ്. So input എങ്ങനെ output ആയി മാറുന്നു, ഒരു relationship ആയിരിക്കും. Okay. So transfer function gives us the relationship between the input and the output, and hence it describes the system. Control system first class input is always represented as R of t and the output is represented as C of t. Now the transfer function of a system is defined as the ratio of Laplace transform of output to the Laplace transform of input at zero initial conditions. That point is very important, at zero initial conditions. Now, നമ്മുടെ ഇൻപുട്ടും ഔട്ട്പുട്ടും ആർ ഓഫ് ടിയും സി ഓഫ് ടി ആയിരുന്നു, അത് ടൈം ഡൊമൈനിലാണ്. സോ ലാപ്ലാസ് ഡൊമൈനിലേക്ക് എത്തി റേഷ്യോ എടുക്കുമ്പോൾ മാത്രമാണ് യു ഗെറ്റ് യുവർ ട്രാൻസ്ഫർ ഫംഗ്ഷൻ. സോ ഇറ്റ് ഇസ് ട്രാൻസ്ഫർ ഫംഗ്ഷൻ ഇസ് ലാപ്ലാസ് ട്രാൻസ്ഫോം ഓഫ് ഔട്ട്പുട്ട് ടു ലാപ്ലാസ് ട്രാൻസ്ഫോം ഓഫ് ഇൻപുട്ട് വിത്ത് zero initial conditions. So if I have represented my transfer function as g of s, then if my input is r of t, my Laplace transform of input is going to be r of s. And if my output is c of t, then the Laplace transform of output is c of s. So the transfer function of the system will be g of s is equal to c of s by r of s. And you can see that the output c of s can be obtained by taking the product of your input r of s as well as the transfer function g of s.